Hello everyone, I am Subhadeep Dey, lecturer of Automobile Engineering Department, COOCHBEHAR Polytechnic. Today I am going to teach you spring from advanced strength of material. Like our previous video, we have divided this chapter into three parts. In part number 1, we are going to discuss about various types of spring and its nomenclature. On second part, we are going to discuss about how the stress is developed on a spring as well as how it's deflect, and on third part we're going to discuss some numerical problem related to spring. So let's begin with part number 1. So what is spring? By definition, any elastic member which can deform under a force can act as a spring. The main function of a spring is to deflect under a load and to recover the original shape when the load is released. Now you may ask that means each and every elastic member can act as a spring? The answer is no, because the term is normally used for those members that deform considerably under the action of force without exceeding the safe limit of stresses. Now let's have a look the function of spring. In general, springs are used to absorb energy and release the same according to the desired function to be performed. For example, spring of a clock. It also absorbs shock. For example, spring used in automobile. It also deflects under external force to provide the desired motion to a machine member, such as spring used in weighting machine, safety valves, clutch, governor, etc. Now let's have a look at the types of spring. According to its design, shape, working principle, spring can be various types. Let us take some following example. Coil or helical spring. It is the most common type of spring used in our daily life. Constant force spring. This spring made of a very thin metal sheet, and it is used in our mechanical clock. Leaf spring. This spring mainly used for suspension, and you can find this in truck, rail wagon. Machine spring. This spring mainly used for heavy duty work, and it is made from a solid shaft machine by using CNC. Wave spring. This is a very new concept. If you have some space restriction, on that case, instead of using coil spring, you can use wave spring, because the length of the wave spring compared to the helical spring is very less, and the performance remains same. Bevel spring. This spring basically a washer which acts like a spring. Now you have some idea about the different types of spring available in the market, but according to your syllabus, we only consider the coil or helical spring. So let's look for the details. So what is coil or helical spring? A coil spring is a mechanical device which is typically used to store energy and subsequently release it to absorb shock or to maintain a force between contacting surfaces. They are made of an elastic material formed into a shape of a helix which return to its natural length when unloaded. Now let's have a look for this following example. Now consider you have a helical spring and you compress it by using your two hands. Now due to the compression force, the height of the spring get reduced. Now if you release your upper hand, from top of it, this spring will come to its original position. That means whenever you release the pressure from it, it will regain its original shape and size. So this is how coil spring work. Now let's have a look different types of helical spring. First is compression spring. A compression spring is designed to operate with a compression load. So the spring gets shorter as the load is applied to it. In general, we'll find this in our shock absorber, spring matrices, inside our electric switches. Extension or tension spring. Extension spring is designed to operate with a tension load. So the spring is stretched as the load is applied to it. We generally find this spring in our brake drum, bouncy decoration that hangs from ceiling. Torsion spring. Unlike the above type in which the load is an axial force, the load applied to a torsion spring is a torque or twist force, and the end of the spring rotates through an angle as the load is applied. That means in our previous case, we basically applied load axially. It could be a compressive, it could be a tension force. But in case of torsion spring, instead of applying an axial load, we basically apply load on its this end as well as in this end. This type of spring you can easily find out in some paper clip as well as the clips which we have used for drying our cloth. Next is variable rate spring. A variable rate spring doesn't have the same spring rate throughout its axial length. You can have a progressive change in spring rate or more abrupt change. Let's have a look these two examples. If you take the first figure, in this figure, if you take the outer spring, you can see the distance between any two consecutive coil keep increasing in a progressive manner. So this is basically a progressive rate spring. Now let's take the second example. In this case, you can find out that the distance between any two consecutive coil has changed abruptly. From here, the distance between any two consecutive coil almost remain constant. From here to this, it has changed abruptly. Next, open coil helical spring. Where of the open coil helical spring is wounded not so tightly, and thus sufficient space or gap exists between two adjacent coils. So if you look at this figure, you can find between any two adjacent coil you have sufficient gap. So this type of spring basically used for compression. This type of helical spring are referred as a compression spring as they strongly resist compression. This spring have a high pitch which create large space between the coils. Next is closed coil helical spring. Where of the closed coil helical spring is wound tightly provided no gap between two adjacent coil of the spring. Now let's see this figure. In this figure, you can easily find out that gap between any two consecutive coil is almost zero. So in this spring, you can't apply a compression load. Rather, you can apply a tension load so that it will elongate. That is why this helical spring variant are also known as extension or tension spring. The closed coil helical spring are designed to resist twisting as well as stretching. Now let's have a look different nomenclature used in our coil spring. For that, let's just consider the front view of this spring. In this figure, this D basically represents the wire dia, ID represent the inner diameter of the spring, OD represent the outer diameter of the spring, and the average between inner dia and outer dia represent the mean dia. P represent the pitch, which is the distance between any two consecutive coil. Mean diameter of coil. It is the mean distance between the spring outer and inner diameter ring, and it's act as a specification of a spring. For example, if you have the outer diameter of a spring and if you also have the wire diameter of a spring, so if you subtract the wire diameter from the outer diameter of the spring, you will get the mean diameter of the spring. Similarly, suppose you have inner diameter of the spring and you also have the wire diameter of the spring, so if you add wire diameter with inner diameter, you will get the mean diameter. Solid length. Solid length is defined as the axial length of the spring which is so compressed that the adjacent coil touch each other. In this case, the spring is completely compressed and no further compression is possible. Suppose you have a compression spring and you have applied some compression force, so that the gap between any two adjacent coil almost becomes zero, like this. And on that case, if you measure its length, this length is basically known as solid length, and if you unrelease the pressure, on that case it will come to its original length, that is known as free length. And this is how you can calculate the solid length. Solid length, that is equals to NT into D, where NT represents total number of coils and D represent the diameter of the wire, that means this. Spring index. Spring index is the correlation between the mean diameter of a spring and the wire diameter of a spring. This proportion will determine the strain of the spring, the stresses induced on the spring, and the manufacturability of the spring. So spring index basically the ratio between the mean diameter of the spring to the wire diameter of the spring. For example, this is represent the small index and this is represent the large index. Energy stored in a spring. Now, before we calculate how much energy a spring can store, first we need to understand elastic potential energy. So what is elastic potential energy? By definition, elastic potential energy stored as a result of deformation of an elastic object, such as the stretching of a spring, and mathematically the energy stored on a spring is equal to the work done to stretch the spring. Now, according to the Hooke's law, the force required to stretch the spring will be directly proportional to the amount of stretch. So, if F is the applied load and let X is the deformation of the spring due to the application of this force F, so we can say by Hooke's law F is proportional to X, where we can again write F, that is equals to K into X, where K represent the spring constant. Now let's have a look in this figure. In this figure, Y direction represent the force which we have applied on a spring, and X direction represent the deflection of the spring. Now you can see, if you keep increasing your force, or if you keep increasing your applied force, the deflection of the spring will also increase. So this is basically a linear graph. Now in this graph, if you want to find out the total work done due to the application of this force F, you can easily find it out by calculating the area under this triangle. Now this total work done under this triangle is basically represent the elastic potential energy. So work done, that is equals to, we know, force into distance, and this work done again is equal to the elastic potential energy, that is del PE, and this work done can be represented by the area under this triangle, which is nothing but half into F into distance x. And if you put the value of F that is equals to K into x, you will have work done equals to, or the potential energy stored on a spring, that is equals to half K x square. And this is how we represent the potential energy stored in a spring. For an unstretched spring, potential energy always remains zero, and if you apply some external force on that spring, and due to the application of that external force, let the spring deform at a distance of x, on that case the potential energy P, that is equal to half K x square, where basically K represent the spring stiffness. So in this video, so far we have discussed different types of spring, different nomenclature, as well as how much energy it can store. In our next video, we're going to discuss the different stresses developed on a spring, as well as how the spring will deform. So thank you everyone. See you in our next video.